Hey everyone, in this video we're going to learn how to factor by grouping. Our first example, factor the following expression, which is x squared times the quantity x plus 4 minus 3 times the quantity x plus 4. Now in order to factor this expression, we're going to have to find a greatest common factor. And to do that, it's helpful to identify two separate terms. The first being x squared times the quantity x plus 4, and then 3 times the quantity x plus 4. And if we treat this expression as just two terms, what we'll notice is that each term has a factor of x plus 4 in it. So then the greatest common factor between the two terms is x plus 4, so we can factor out x plus 4, and we'd be left with x squared minus 3. And there we've factored the expression that we were given. Okay, so what we use is the greatest common factor technique. This is going to be key in doing factor by grouping. The only difference is we're going to have to set a polynomial up in this form. So we're going to learn how to do that, and once we get it to this point, then we're identifying the greatest common factor, and we'll be able to finish factoring the problem. So what if we simplified that example? So if we multiply out the polynomial in the previous example, we would get x cubed plus 4x squared minus 3x minus 12. So that's in standard form. How many terms does this polynomial have? It has 4 terms. And what is the greatest common factor of all the terms? Well, looking at it, it looks like the greatest common factor would just be 1. So we can't just take a greatest common factor of the polynomial in standard form. All we would get is 1. And we wouldn't be able to factor it the way we did in the previous example. Right? We've already seen that this can be factored. So how do we get there on our own? Well, the key here is to group terms within the polynomial together, hence the name factor by grouping. So group the first two terms together and group the last two terms together. That's going to give us x cubed plus 4x squared when grouping the first two, and then minus 3x or negative 3x minus 12 grouped together as well. Now we're going to factor each group separately. So we're going to treat this set of parentheses as its own GCF problem. So looking at x cubed plus 4x squared, the greatest common factor is x squared, and we'd be left with x plus 4. Then plus. Now we have negative 3x minus 12. So some of you may be thinking that the greatest common factor is 3. And that's correct, but the only issue with 3, and I'll write it off to the side, is then we'd have negative x minus 4. And remember what that problem in the first slide looked like, and how we were able to identify x plus 4 as a factor in each term. Well, if I leave it like this, I don't see that x plus 4 in each term. So what that means is with this greatest common factor of a 3, we need to also factor out a negative 1. So what we want to do is factor out a negative 3, because then that's going to leave us with the factor of x plus 4. Okay, so our decision to factor out a negative or not is based on making a greatest common factor in each of our two terms. So by factoring out negative 3, we now have x plus 4 as a factor in the first term, right here, and in the second term. Okay, so do the groups have a common factor? Yeah, we identified that as x plus 4. So now we're going to factor this out like we did in the first example. So that's going to give us x plus 4, and we'd be left with x squared plus negative 3, which I'm going to write as x squared minus 3. So it is a little bit cleaner. Okay, so we have now factored a 4-term polynomial by using the grouping method. So let's run through that quickly again. We're going to start with our 4-term polynomial, and we're going to group 2 terms together at a time. So let's say the first 2 and then the last 2. Really could be any 2 terms. Okay, we can change up the order of the interior, the 2 middle terms, but typically we're given a polynomial in standard form, so there's no reason to move the terms around. Then we take a greatest common factor of the groupings, and then what we should hopefully identify is another greatest common factor that we could pull out of those two terms to get our final factorization. Now, I do want you to understand that the technique of factor by grouping doesn't have to be 2 and 2. It could be 3 and 1, or if you have more terms, it can be 2, 2, and 2. Hey, but the type of grouping that we're going to look at in this video is taking 4-term polynomials and grouping them in groups of 2. Later on in this unit, we'll look at some of those more advanced examples where we're going to use factor by grouping, but maybe in a situation of 3 and 1, as opposed to 2 and 2. Okay, so factor the following polynomials. And we're starting off with x cubed minus 5x squared plus 2x minus 10. So we'll start by grouping. That's not a great parentheses. Start by grouping the first two terms together and the second two terms together. Okay, so the greatest common factor of the first two terms is x squared, and then we'd be left with x minus 5. The greatest common factor of the second two terms is positive 2, and then we're left with an x minus 5 as the factor. And comparing our two terms, right, this term and this term, we notice that each term has a greatest common factor of x minus 5, which can be factored out, and we're left with x squared plus 2. Our next example, 2a cubed plus a squared plus 14a plus 7. So we'll group the first two terms together and then the second two terms together. Taking a greatest common factor from the first two terms, that's going to be a squared, and we'll be left with 2a plus 1. The greatest common factor of the second two terms is plus 7, and we're left with 2a plus 1. So I'm not going to put brackets around in this example, but now we have our first term and our second term, and we should notice that each term has a factor of 2a plus 1. So we can factor out a 2a plus 1, and we'd be left with a squared plus 7. Okay, perfect. Now, some teachers may also have you draw a dotted line down the middle to visually split the 4-term polynomial in half. That's fine. If that helps you, I would encourage you to do that as well. 3t to the 4th plus 12t cubed minus 5t minus 20. Okay, so we're going to group the first two terms together and the second two terms together. I'm going to put a plus sign there just because we want to make sure that we understand we're adding the two terms together. Greatest common factor of the first two terms is 3t cubed. That leaves t plus 4. And then plus. So the greatest common factor of negative 5t minus 20 is 5. But we want to factor out a negative 5 so that our factors are the same. So by pulling out a negative 5 as our greatest common factor, that leaves us with t plus 4. Okay, so notice the advantage to pulling out a negative 5 as our greatest common factor. We now have t plus 4 in each term. So we can factor out the t plus 4, and then we'd be left with 3t cubed minus 5. Okay, our next example, 6x cubed minus 8x squared minus 27x plus 36. Group the first two terms together, second two terms together. Again, put that plus in between them. The greatest common factor of the first two terms is going to be 2x squared, and then that will leave us with 3x minus 4. And then plus, so the greatest common factor here, again we want to factor out a negative because we want that 3x to be here. So factor out, let's see, 2736 has a greatest common factor of 9. So we'll factor out a negative 9, and that will leave us with 3x minus 4. Right, just to make sense of that, if we're factoring out a negative 9 from positive 36, the factor that would remain is negative 4. Right, negative times a negative is a positive. Just to make sure we're clear with that value. Now, 3x plus 4 is the greatest common factor in each of our first terms, or our first term and our second term, I should say. So we can factor out the 3x minus 4, and what's left is 2x squared plus negative 9, which is minus 9. And again, as a reminder, with any factoring problem, we can distribute out our factors, and we should get the original polynomial. Okay, so we always can check our answers here. Next up, we have xy plus 10x plus 7y plus 70. So it looks a little different. Now we have two variables amongst our four terms, but we're going to approach it the same way. So we'll start by grouping the first two terms and the second two terms here. So our greatest common factor of the first two terms, that's going to be x, and we'd have y plus 10. And our greatest common factor of the second two terms is plus 7, and then y plus 10. So y plus 10 is the greatest common factor in the first and the second term. So we'd have y plus 10 times x plus 7. And our last example, a times b squared plus 4ab minus 3b minus 12. So we can group the first two terms. Second two terms, we'll put that plus sign in the middle. So the greatest common factor of the first two terms is ab, and we'd be left with b plus 4. And our greatest common factor of the second two terms would be, well, the greatest common factor is 3, but we want the factor to be b plus 4, so we'll factor out a negative 3, and then we will have b plus 4 left. So we have b plus 4 as the greatest common factor, and then times ab minus 3. Okay, so essentially factor by grouping is just doing the greatest common factor twice. The key is knowing how to set it up, knowing to group the first two terms and the second two terms together, at least in the examples that we're looking at. Again, this method can be expanded. You can group the first three and then the last term, and we'll see those later on. The last thing I want to show before we end this video is what if we took that example, which is ab squared, and let's switch the two middle terms. So minus 3b plus 4ab minus 12. Would that change our answer? Okay, so we'll group the first two terms together and the second two terms together. Taking a greatest common factor from the first two terms, we have b, and we'd be left with ab minus 3. And the greatest common factor from the second two terms is plus 4, and we'd be left with ab minus 3. So ab minus 3 is the greatest common factor that we can take out, and we'd be left with b plus 4. So notice that's the exact same factoring. Now the order is changed, but that's not an issue because of the commutative property of multiplication. Okay, and this idea of the middle terms being switched is going to be important in using factor by grouping to accomplish another factoring technique in the next video. So practice with the factor by grouping. We're going to use it in our next type of factoring, or to build up our next type of factoring, and then we're going to go from there in our factoring unit. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.